Okay, we're gonna
All
continue
right,
with
we're
the
gonna try to
5.6 day 1
do
notes with number 8, which
L'Hopital
is
notes, section
the limit as x
5.6,
approaches 0 from the right of x cubed,
and see how this goes.
cotangent of
So first of all,
so the first thing
if you're
we want to
using
do is plug in
L'Hopital's
0.
rule,
So I'd have 0 times the cotangent
it has to be
of
the
0. Now,
indeterminate
this is
form.
where this one
And
might
the
get a little bit
indeterminate form
difficult because
is one of these.
you may not remember what the cotangent of 0 is. It's
So
undefined.
After
but
you
we
substitute
need to
in
know,
the number, which is always our first option when we're doing limits.
towards?
If you get any one of these things, 0 to the 0, 0
you remember,
divided by 0,
and if you don't remember, you can always graph the
1 to the
cotangent
infinity
on your calculator.
power, infinity minus infinity,
the cotangent
infinity divided by
graph,
infinity,
or
or
the tangent
0
graph,
times infinity,
or
or
like this.
infinity to the 0. If you get any of those things, then you're eligible to
cotangent.
use
Tangent goes the other
L'Hopital's
way.
rule,
And
which
then,
can come in handy because it
there's
will
an
allow you
asymptote
to
there.
find limits.
And when you were
in some
graphing these in
cases where you
pre-calc,
couldn't do it any other
looked
way.
at, for the most part, you
And
looked
in other
at one
cases,
fundamental cycle, and this
it's a
is
lot
one
easier
fundamental cycle.
to do
starting
it than the
at
normal
0
method that we had talked about in the
and,
first semester.
Going towards
Okay,
pi.
so
So
the directions for these first set of problems is
you
use
look
the
at
techniques
the
from the first
cotangent
semester,
of 0,
and then
this is 0 right here. You can see the cotangent of 0 is shooting
All right, so
up
let's
towards
start
infinity.
with the techniques from
so
the
this
first
would be
semester.
0 times infinity.
All right, so the first technique is to plug in
and that is
use
an
substitution.
indeterminate
If you plug that in,
so
you're going
you
to
can
be
do
dividing by
L'Hopital's.
0, so that's no good.
Now the problem here, or another problem is,
then usually the next
in order to do
option was
L'Hopital's, I have to have a
factoring, and
fraction.
this one is
And I don't have a
factorable.
fraction here.
So we do the
But I
limit
could
as x
rewrite
approaches
this
negative
as the
1
limit
of
as x approaches 0 from the right
2x
of x
minus
cubed
3
over
and x plus 1
tan x
over x plus 1, and then those cancel.
That's
And then if
essentially
you
1 over
substitute
tangent
in
x, which is
negative
the same as
1,
cotangent x.
you don't have an issue
And
anymore.
then
It becomes negative 5.
I can take
All
the
right, so that
derivative
was
of the top,
first semester,
which would be
you might
3x
have to go
squared,
back and look at those
and
notes,
the derivative of the
because,
bottom, which is secant squared
we haven't done that
x.
in a while. That's the very first thing that we did
And then plug in 0
in the fall.
And if I get 0,
All right, so
plug in
now
0
we're
on the
going
top,
to
I get
do
0.
L'Hopital's
And
rule.
then if I plug in 0 on the bottom,
And L'Hopital's
I'm
rule
looking for
says
the
if you
secant
have the indeterminate
of
form,
0,
you can take the
and
derivative
secant
of the
0
top
is actually
and the
1,
derivative of the bottom,
and 1 squared
and
would
then
be
go
1.
from there.
So this is
So
0 over 1
we have to make sure
which is 0.
L'Hopital's rule applies. So if you plug
the
in
limit
negative 1
of this
into
guy
the numerator, you're going to
is
get
actually
0. And in the denominator, you're going to get 0.
All right.
And 0 divided by 0 is one of the
Okay,
indeterminate
so
forms.
let's go to the next one.
So we can do L'Hopital's. All right, so L'Hopital says we're going to
plug in
do the limit
infinity
as
here,
x approaches
I would
negative
get
1.
infinity
And we're going to find the derivative of the top, which is just 4x
of 1
minus
over
1.
infinity.
And the derivative of the bottom is 1.
And the tangent of 1 over
if you plug
infinity
in now,
really
there's no issue with the
tangent
denominator.
of 0
You
because
come
1
up with
divided by
5, and that matches our other
infinity
answer,
is
which it
0.
should. If it doesn't, something's wrong.
And the tangent of 0 is 0.
that's
So this would be
L'Hopital's.
infinity times 0. And that is
Okay,
an indeterminate
so if you
form.
have, I don't have a lot of room
L'Hopital's
here,
on
so I'm
this
going
one.
to be erasing a lot of stuff. So if you need to
Okay,
rewind,
now my two terms are
and pause
x
it and copy some
and
stuff down
tan
before I
1
move
over
on
x.
to the next
Those are my
thing. Feel
two
free to do
terms.
that.
And so technically, I don't have a fraction on this one either.
Okay,
I know I
so
got 1 over
number
x,
2,
but that's
we'll do
part
our
of
old
that
method.
term. That's not a fraction.
If you plug in
So
0,
I need to rewrite this. I'm going to rewrite
Again,
this
you're gonna
as the
get,
limit.
in this case, 0
as
on
x
the denominator,
approaches
but you're also going to
infinity.
get 0 in the numerator,
I'm going to
which is,
leave
by the way,
the
0
tan
divided
on
by 0,
top, so
which tells us we can do L'Hopital's for
x,
part B.
and then
but it
I'm
also
gonna
tells
take
us we
that
can't use
x,
substitution here.
and I
So
want
if
to
you
move it
remember,
down to
this
the
was
bottom,
the
and I can do
sandwich
that by
theorem,
just saying
and
x to the
like I
negative
said, you
1.
may have to go back and look at the notes.
That's
But
the
what we
same.
want to do is we want that
Okay,
to match
then I'm also
the bottom. So if we got
gonna
4x
rewrite
on
this
top,
as,
we need 4x on bottom.
tan
So if we do the limit as x approaches
x to the
0,
negative 1, that's the
and
same.
we have
as
sine
well.
4x, and then on the
Okay,
bottom,
so
we're gonna
then,
turn that into 4x by multiplying by 2. So that becomes 4x.
So we already know we got
But in order
indeterminate
to
form,
balance
so
it
we'll do
out,
the
I got to
derivative of the
multiply the
top,
top
the
by 2 as
derivative
well.
of the top,
So that
the
I'm
limit
essentially
as x
multiplying
approaches
by 1.
infinity,
And then
derivative of the
this
top is secant squared
even though if I plug in, do substitution,
x
I'm
to the
gonna get
negative
0 over
1.
0 again.
And then I have
But
to
we
chain
know
rule
by the
that.
sandwich theorem
So
that
that would
that's
be
equal to
negative
1.
x to the negative 2.
And also you could look at
And
it
then the
graphically.
bottom
And
would
so
be
this becomes 2
just
times
negative
1,
x to the
which is
negative 2, which is nice.
Okay, so
Because
that's
that essentially those cancel each
the
other
old
out.
method. We already
So
know
I've got
by 0 divided by 0 that
really
we can do L'Hopital's.
The
So let's
I
do
got
that.
secant squared.
So we would have the
1 over
limit
x.
as x approaches 0.
That's what that would simplify
the derivative of
And
sine
if I
4x,
plug
which would
in
be cosine 4x. But then we got a chain rule
infinity
that, so
here,
4 up front.
it would be essentially
And then the
secant
derivative of the bottom
squared
which is
of 1 over
just
infinity, which would be 0.
Okay, so if I substitute in 0
And
now,
the secant of 0
I'm going to get
is
4
actually
times
1,
the cosine
so that'd be
of
1
0,
squared, which is 1.
and the cosine of
So the
0
limit
is
here
actually
is
going to be
1.
1. So this
Limit of
becomes
that
4
function is
times
1.
1 over 2, which is 2. And that matches that.
All
which
right.
Again, it should. All right. I'm going to erase that. So if you need
Okay,
to
so
pause
this
it,
one,
pause
if I
it
plug in
before
infinity,
I go
I'm
on
going to
to number
get
3.
1 plus 1 over infinity, which is 0.
Okay, number 3.
So this would be 1
the
plus
method
0
from the first
to
semester
the infinity, which is
um,
really just 1 to the infinity.
Well, first of all, if I plug in infinity, I'm going to get infinity
All right,
on
that
the
was
top.
not a coronavirus cough. I just got some allergies.
So,
So
I don't
1
know
to
what
the
that is.
infinity is
Actually
a
I think we talked about this
indeterminate
before,
form.
but if we haven't,
I know
most
it seems
people
like it
think
should be
infinity
1,
divided by infinity is
but-
1,
and it might be,
but
we'll
that's not
see
necessarily
at the end of
true.
this
It could
problem.
be a
If,
lot of different
in
numbers.
this case, 1 to the
There's
infinity
infinitely many
is
answers
actually
to
1.
that question. It just depends on how quickly
Okay, so
it's going towards infinity.
Whenever
But
we
that is
had
definitely
that,
an indeterminate form,
exponent
so I
as
can
a
use
variable,
L'Hopital's when I get to part B for sure.
One of the techniques that we used,
the method that we
a
used
while
first
ago
semester
was to divide everything.
take the log
by,
of both sides
sometimes
of the equation
it
to
was
get
x.
that
Actually, most of the time it
exponent
was x, but in this case, I'm going to divide by x squared.
that power position,
2x over x squared,
because that's one of the
plus 1
properties of
over x
logarithms.
squared. But we don't have another
Over
equation, so we're going to
4x
set
squared over
y
x squared
equal plus x over
to
x
the
squared.
limit.
All right. As x
So hopefully you
approaches
remember that
infinity,
method.
the reason why it's x
of
squared instead of x is because you
x,
take whatever degree is the
Or,
largest
no.
and you divide by that. So we have an x squared, so we're going to divide
1
by x squared.
plus 1 over
All right,
x
so on the top,
to the x.
2x over
Okay, so
x
all I've done
squared
there is
is throw in a
simplifies to
y
just 2
to
over
make
x.
an equation so that I can
And
take the
I
log
can't
of
do
both
anything
sides.
with
So I'm
1
going to take
over
the
x squared.
log
That's
of
simplified.
y,
The bottom,
and then
4x
I'm going to
squared
take
over
the
x squared
log
becomes 4
of this.
And then
So it'd be
x
the
over x
limit
squared becomes
as
1 over
x approaches infinity of
All right,
ln.
so then we're going to plug in
I'm
infinity.
purposely leaving a spot
And if
there
I plug in infinity,
because that's where that
I'm going to
very-
have
that
2
exponent's gonna
divided
go.
by infinity.
1
plus
plus
1 over infinity
1 over
squared
x,
over,
and then I'm going to take
4
that exponent
plus
and I'm
1
gonna
over
stick it out
infinity.
front, so that becomes x. right
Okay,
there.
then from the first semester, we
Okay.
know that if we have a
So
constant,
hopefully you followed that.
doesn't matter what it is, if
Then
we divide by infinity, it's going to
um,
get really, really small, and essentially it's going to become 0. And if we take 1 and
I'm
divide it by
going
infinity
to,
squared, it's also going to be 0.
essentially
On the
rewrite
bottom,
this side.
We have
So
4 plus
if I
1
plug
divided
in
by infinity, which
infinity
is also
here,
0.
I'd have infinity
And,
times the natural log.
so this
of
becomes
1
0
plus
plus
4
4.
over infinity.
And that is
And,
0. That is
the
not
natural. So that
indeterminate.
this
That's
part
0.
right
We
here
can have
1 over
0
infinity
in the
would be 0.
numerator.
So
As
this
long
is
as we
really
have
just going to
something
be the
else in the
natural log of
denominator
1.
besides 0.
Natural log of 1 is 0.
All right,
so
so
this
the
is
limit
really
as x approaches
infinity
infinity of this
times
function
0,
is 0.
which is one of our indeterminate forms.
Okay, so I'm about
All
to
right,
erase
so
this.
I'm
and
going to
then we'll
rewrite
go to
this very
L'Hopital's.
similar to the last problem. So I'm going to do the limit as x approaches infinity, and I'm going to do the natural log of 1 plus.
Okay, so
I'm
this
gonna
is
rewrite
part
that as
B.
x
We
to the
already
negative
know
1
it was infinity
over,
divided by infinity, so we can do L'Hopital's. So we'll
and
go
then
the
I'm going
limit
to take this
as
x to the
approaches
negative
infinity,
1,
or
we'll
this
do
x,
the derivative
and
make
make it
it
top,
x to the
which
negative
is
1, so I
2,
can have my
and the derivative of the
division.
bottom is 8x plus 1. Okay. All right. So that's going to be
now
if I plug in infinity.
I can
2
do
over
L'Hopital's
infinity,
on this
that
thing
is
right here.
If I take a number and divide by
All right,
infinity,
so we're going to do
it's going to be 0.
the limit,
And that matches our first
as
answer.
x approaches infinity.
All right.
We're going to do the derivative
Let's go
of the
to
natural
number
log
4.
of 1 plus x to the negative 1.
Okay, now this,
And we know the
directions here say
of
evaluate
any
using
natural log is 1
L'Hopital's rule
over
if necessary.
1
So
plus x to the
it's kind
negative
of your
1.
choice. If you
And then we got a chain rule,
method that
the
we've
1 plus
already
x to the
learned, that
negative
seems
1.
like it would be good.
The derivative of 1 is 0. The derivative
factoring
of
and
x to the
canceling,
negative
something
1
like
is
that can be
negative
done
x to the
quickly and
negative
easily,
2.
then you should use that.
And
if
we're
you
going to
don't,
divide that
and
by
it's
the
an
derivative
indeterminate
of the
form,
bottom,
then L'Hopital's might be
which
the way to
would
go.
be negative x
All right.
to the negative
So
2.
I'm going to plug in.
All right, so
If
again,
I plug in
if you get
2,
confused
even though it's
here,
approaching
pause
from
it,
the left, I
look
still
at it,
substitute in the
see
number.
if you follow it.
I get 0
All right,
divided
good
by
news
0.
is I can cancel
So
those.
that's the indeterminate form. So we can do L'Hopital's.
All right, and
so let's
so all I got
find
left,
the
if I can
derivative
squeeze this in,
of the
is
top.
1 over 1 plus, and I'm going to rewrite
so
that as
would
1
be
over x.
1/2 times 4 minus
Okay.
x squared.
So if I plug in infinity
to
now,
the negative
I'm going to get
1/2.
1
And then you'd have to chain
over
rule
1 plus
this,
1 over
which would give me
infinity.
negative 2x.
And we know that is
All right,
0.
and that's all
So this
over
just becomes
the
1 over
derivative
1,
of the bottom,
which is 1.
which is just 1.
All right, now that's not the tricky part.
Okay.
So that is not equal to
so I could
the limit.
cancel that 2 and
And
that
I know
2.
somebody out there is saying,
And
I know you are.
I'm going to take that
You're saying what
negative
that's equal to.
1/2 exponent,
That's
bring
equal.
it down the
That's
bottom.
not what y is equal
So,
to. That's what natural log of y is equal
This would be the limit as x
So the
approaches
natural
2.
log of
Remember,
y
we got to
is
keep
equal to
writing that.
1.
Otherwise,
I
I gotta
want
take the points
y,
off.
and we've done this a million times.
So on
We
top,
know
I'd have
we're gonna
negative
do
x.
e to the
On bottom,
e
I
to
got
the,
4
and this
minus
becomes
x
y
squared.
equals e to the first
1/2
power, which
power.
is just e. So my limit
Okay,
is e.
so if we substitute in 2
So
now,
essentially, in this
I'm gonna
particular
get 2 on
problem,
top, negative 2 on
1
top,
to
and
the
on bottom, I'm
infinity
gonna be dividing by 0
is
again.
the number e,
So
which
that's
is
no
about
good.
2.72.
So I'm dividing by 0.
So
Um,
that's what I was talking
It
about.
is not a candidate for
indeterminate form
L'Hopital's
is not
because
intuitive.
it is not 0 divided by 0.
One,
so I
if you
can't
asked
do
anybody on
L'Hopital's
the street
again.
what 1
And
to
actually,
the
you
infinity
can,
power is,
as
I
long as
guarantee you
it
they would all
is
say
the
it's
indeterminate
1.
form, you can do L'Hopital's.
But
several times.
in this case,
Matter
it's
of fact,
not.
There was
It's
a
2.72.
problem on last year's final where you were required to do L'Hopital's, I think, 3 times.
I think this is the last
in order to
one.
get the
Yeah.
answer.
Good. Thank
But
God.
you just have to remember you
All
can
right.
only do it multiple times.
So
If each time you do it, after you do the substitution,
if I plug
it's
in
indeterminate form.
2
And
here,
this would not
I'm going to
be.
get
This would
1
be
over
2,
0, and I'm gonna
negative
be
2
dividing by
over
0
0
there also.
and that is not indeterminate.
So you can't do straight
All right,
substitution.
so we're kind of
All right,
stuck here. But if you
if
remember,
I look at this, and actually,
when we
this
were
is kind of silly
approaching
to do it this
from
way
the
because
left to the right,
there
we
is a
could
common
substitute
denominator. So I
something
can write this
in
as a single
that was
fraction,
close to it.
but I want to show
on
you
the left side or the
one
right
of the
side. So
other
since we're
indeterminate
approaching from the
forms.
left,
So
I would plug in 1.9.
if this was a real problem,
so the top
write
would
it
be
as a
negative
single fraction and
1.9.
go from there. But
And then on
if
the
I
bottom,
plug in
if I plugged in
like something a
1.9 here
little
and squared
bigger than
it,
2, because
I would
approaching
get
2 from the right, so 2.1.
almost 4. It would be something
So that,
really,
then I'm going to
really
get
close
1
to 4.
over
So when I
a number a
subtracted it
little
from
bigger
4,
than
it would
4
be
minus
really
4,
small,
which is
be a
gonna
very
be a
small
number.
and
So
then
that's going
taking
to
the
be
square root
1
of that
over
small
a
number.
really small number.
And
it's a positive small
anytime
number.
we have a constant
minus
divided by a small number,
and if I plug in
then
a number a
it
little
actually
bigger than 2,
grows, and
into
goes
the,
towards infinity. And in this case, since it's a negative, it would go
that's going
towards
to
negative
be
infinity.
something really
So
close to 1.
In essence, this limit does not
And
exist.
then on the
There is no
bottom,
limit.
it's going to
But
be
also
a
we
really
can
small
answer
number
it.
again.
Where does it go? And in this case, it's going
So,
towards negative infinity.
This is
All right.
1 divided by a small number is infinity.
So that one we kind of
And
used
1 divided by a
L'Hopital's
small number is
and a
infinity.
technique.
And
from
so in
first
this case,
semester.
we have infinity
And
minus
don't
infinity,
forget,
which
I could
is
not use L'Hopital's
indeterminate.
again.
I know again, it
because
seems like it should be
It
0.
was an indeterminate form. After I
Anything
did it the
minus
first
itself
time.
is equal to 0, but weird
Okay,
things happen
so
when
let's
you go
go
towards
to
infinity.
number 5.
So let's see if this is 0 or not. Okay, so then I am going to rewrite
Okay, so if I
this,
plug in 0,
with a single
I get the
denominator.
sign of a
So
times 0,
the
which
line
is the
as
sine
x
of
approaches
0.
2,
and the sign of 0
From the
is
right.
0.
And then this would
same with
become
the bottom,
1
that would give you
minus
0, and 0 over 0
square
is the
root of
indeterminate
x
form, so we
minus
can use
1
L'Hopital's
all
here.
over x squared minus
So we'll
4.
do limit as x approaches 0, and
Okay.
the derivative of the top would
if
be
you
cosine
did
AX.
substitution here,
And then I would
you would get
do the chain rule, and I'd get an A out
1
front.
minus
And
1,
then
so 0
the
on
bottom
top, and
would
you get
be
0 over 0.
cosine
So you could
BX.
do L'Hopital's on this if you
And then
wanted
I'd
to,
get
and
a
it
B
would
out
work.
front. And
But
then
actually,
if I substitute in
think
0 now,
I'm going to do
I'd get the cosine of
conjugate.
0.
I'm
and the
not
cosine of
exactly
0
sure
is
why I'm
1,
doing
so
this. I
this
think
would
it
be
might be
A
easier.
times 1.
So
And the bottom would be B
that's my
times
choice.
1.
I can use whatever
So
method
this would simplify to
I
A over
want.
B.
So I'm going to
That would be
multiply
it.
by
That's
1
all you can do
plus
for
the
that one.
square root of x minus 1.
Okay, in that case,
over
L'Hopital's
x
was very handy. Made that problem a
1
lot easier.
plus the square root of x minus 1.
Okay, so let's take a look at 6. If I
Okay,
plug in
So
infinity,
that was
I'm
from
gonna get
first semester, also from
e to the infinity
pre-calc,
divided
so
by
you should
2,
remember
which,
that,
which
multiplying
is
by the
still
conjugate.
infinity.
And then
And
on the
bottom,
top,
I'm gonna
that's
get
going to
infinity.
give me
Infinity over infinity is an indeterminate form, so we
1,
can use L'Hopital's.
and then
So,
the middle terms are going to
let's
cancel,
do
and then
limit
minus the
as
quantity
x approaches
x
infinity
minus 1
of, and then we'll do the
over,
derivative
and then
of
don't
e to
distribute
the x
here.
over 2, which is e to the x
so
over
we got
2.
x squared minus 4
And then this is like the same thing as 1
plus the
half
square
x,
root of
right?
x minus 1.
So I got to chain rule that, so that'll give me 1 half
Okay,
constant
so
out
on the
front.
top,
And then the bottom, the derivative of that is 1. Okay,
I would
so
get,
if I plug in infinity now,
negative
I'm going to get
x
1 half times e to the infinity over 2. So remember, e is just a number. It's like
So I got
2.72.
so I'm going to
And we're
change this
taking
plus,
that
this
to a
minuses,
infinity
plus.
power, which
So I'm
is
going to get
gonna
2
be
minus
really
x
huge, like infinity.
over
And then I'm going to take
squared
infinity and
minus
divide it by
4
2, which is still infinity.
times 1
And
plus
so this is going to be infinity over 1. And that
square
is
root
just
of x
infinity.
minus 1.
It's not an indeterminate form. So this
Okay.
limit does not exist.
So if I plug in
but also we know where it goes.
2
So
now,
as we go towards infinity,
something a little bigger
this
than
function
2.
is going towards
So
infinity.
if I plug in something a little bigger than 2
All right.
on top,
Let's take a look at
I'll
this one.
get.
So if I plug in infinity here, I'm going to get e to the infinity, which is infinity.
Well, let's
Infinity
talk
cubed,
about
which is
2 first.
infinity.
So if I
So
plug in
that's
2,
infinity over
I'm going to
infinity.
get 0 divided by 0.
So
So that would be
again,
L'Hopital's
that is
rule.
not 1. Matter of fact, we just did a problem where infinity divided by infinity
All right,
was infinity.
We can do L'Hopital's,
and it
in
all
this.
depends on how quickly
this
it's
one
going
if we
towards
want.
infinity. In this case, it means the top is moving towards infinity much faster than the bottom.
Oh, you know what?
And it's
I just noticed
taking
something
over
that's better than
and
that.
shooting towards
Let's
infinity,
not do L'Hopital's
where
rule.
the bottom is going
Let's
much slower
do
and
2
can't
minus x
fight that
over-
infinity on the top.
I just noticed that
All
this
right,
is
so let's see what
factorable.
this is going to be.
So that's factorable to x plus 2, x minus 2. Yeah, I like this better. Times 1.
So I'm going to
plus
do
square
the
root
derivative of
x
the
minus
top,
1. All right. Yeah, that's going to
which
work out
is
nice.
e to the x.
So the 2
the
minus
derivative of the
x and the
bottom
x minus 2 are not
is
exactly the same. We can
3x
cancel them
squared.
if we put a negative 1 on
All
top.
right, so if I plug in infinity
All right, so I got
here,
negative
I get
1
e to the
over
infinity, which is infinity,
x
over
plus
the bottom,
2
which is also
times
infinity. So
1
it didn't really help,
plus the
but
square
we
root
did
of
get the
x minus
indeterminate
1.
form
All right,
again.
yeah, that'll work out
So
much
we
better.
could do L'Hopital's again.
Okay, so on
So
top,
we'll do the limit
I got a negative
as
1.
x approaches infinity.
On bottom, I can
of
do
the
straight substitution.
derivative
So
of
if I
this
plug in
now.
2,
So the
that's gonna give
derivative
me
of that
4.
would be e to the x
and
over,
if I plug in
and
2
then the
here, that's
derivative
going to
of
give
this
me
would be
2.
6x.
So this is actually
And if I
negative
plug in
1/8.
infinity there, that's going to be e to the
All right.
infinity, which
So
is infinity.
in
and 6
that
times
particular
infinity,
problem,
which is also
infinity
infinity.
minus infinity
Okay,
is actually
so again, didn't help
negative
us,
1/8.
but we have
And what that
infinity over
means
infinity,
is
so I can do
the 2
L'Hopital's again.
infinities are
So I'm gonna
really
do the
close to
limit
each other because it's
as x
almost
approaches
0.
infinity.
So if the infinities
of
were
the derivative
going
of the
towards
top,
infinity
which
at the
is this
same rate,
guy,
then
e
it
to
would
the
be 0.
x divided
But
by the
it
derivative of the
appears that the
bottom,
negative
which would be
1 is
6.
going just a little
And
bit
that
faster.
becomes
And
e
the
to the
reason why I know
infinity,
that
which is
is
infinity
because
over
my answer
6,
was negative.
and infinity over
So that means
6
the negative
is infinity.
1 out.
So the limit
So
of this turns out to be infinity.
If I take this number minus this number and I get a negative, then this
Okay.
one's a little bit
Um,
bigger. All right. And since it's negative
Let's
1/8,
take
it's
a-
so close
actually,
to zero
I think I'm
that,
gonna
that they're
stop
really
there
close to each
and
other. But
just
here's a
'cause I don't
case
want
where
this video to
0
be too long, and
minus
I'll
0
finish this
is
up
actually
with another
negative
video
1/8.
and share it. So let's-
Okay, so I am going to post the homework. I'll do it on portals and I'll do it on GroupMe. Let's stay in contact. If you have questions, let me know. On Thursday, we're going to go live. I'm going to do uh, a video that we meet during our normal classroom time, and we'll talk about some stuff. We'll go over questions, but I need everybody to be online that particular day on Thursday when our class would normally meet, and that's a day one. So we would normally meet at 12:50. So that's the time that everybody needs to be online. I'll send the link out via GroupMe, and we need to do it on Thursday to make sure that this is going to work and that everybody's able to watch it and share in it. So make sure you do that on Thursday. And again, I'll be in touch.